Today we will discuss about the transducers, which is in the 5th unit of measurements and instrumentation. Transducer is an interesting element which is in the measurement and instrumentation sector. First of all, let me tell you what is this transducer. Transducer is a device which converts a non-electrical quantity or a physical quantity into an electrical signal. Right. Let me start with this small block diagram. Let's see, this is our non-electrical quantity. Let me first explain this non-electrical quantity. A non-electrical quantity can be in anything. It can be a temperature, pressure, or light, intensity, or water flow, anything. That quantity, in earlier days, it is very difficult to measure these quantities. So we are in need of certain things, and after the advent of our electrical engineering, this plays a vital role in sensing these physical quantities. So this non-electrical quantity is converted into electrical signals, and these electrical signals will be stored in a place or in a memory which can be retrieved in any time. So this is the thing. So this non-electrical quantity is converted by a sensing element. So this is a process which comprises of sensors, then data acquisition system finally, which we will discuss in the further classes. So now, are you clear what is a transducer? Transducer means which converts an non-electrical parameter or a non-electrical quantity or a non-electrical signal or a physical parameter into an electrical signal, right? Let me give the brief introduction. A device which converts one form of energy into another form. A device which converts one form of energy into another form, we will call it as a transducer, right? So it can be also alternatively, the definition can also be written as a device which provides usable output response. We need an usable output response. Why do we want that usable response? Usable output response. The output response should be an usable one. I want to retrieve that response after some time. There may be say for example, the present situation, the corona problem. We want to record those data all over the world, and we want to retrieve the data, how Italy has played a role or China has played a role. So these kind of things we have to discuss. This is what a device which provides usable output response to a specific input measured, which may be a physical one, to a specific thing which is to be measured in a physical, the measurement will be in a physical quantity. This physical quantity can be in anything. So this is the definition for a transducer, which converts one form of energy into another form, alternatively which provides a usable output response to a specific input measurement, which may be a physical quantity. Now let me explain with an example. Say for example, the mercury thermometer. You could have seen the mercury thermometer in many labs there, or in the physician place with the doctor's clinics, everything. There they will place in the wall, they will place a temperature measuring device, which you can see a mercury thermometer. So next to that you can see some markings like that. So this mercury level may rise or gets decreases. This tells the temperature, room temperature of the room temperature. Okay, so before that it is very difficult to find out the temperature. Without that mercury, it will be very difficult to find the room temperature. So this room temperature, it can be easily measured through this mercury thermometer. So this mercury thermometer is a physical, you just imagine this is a physical quantity which explains that your input signal is a room temperature which has to be converted. This is the movement of the mercury is a mechanical or a physical non-electrical quantity which has to be converted into a again it is a non-electrical quantity into a physical quantity where we can measure the room temperature. So the same thing. In mercury thermometer, a room temperature is measured by the level of mercury increase in the calibrated scale. In the calibrated scale, calibration means what? We have discussed this in the first unit. What is calibration? Okay, calibrated scale. Thus, here mercury thermometer acts as a transducer. This mercury thermometer converts a physical quantity into a measurable quantity, where we are using to measure the room temperature. So now, what are the parts of a transducer? What do you want? Now we are very clear. What is a transducer? What is a transducer? It converts a non-electrical quantity into a non-electrical quantity into a non-electrical quantity into an electrical quantity, or from one energy, one form of physical energy into another form of physical energy. So how it works? What are the parts of this transducer? So it consists of a sensing element. This consists of a sensing or detecting element and a transduction element. So you need to sense that temperature. You need a sensing element, and the other one is to convert that process. First is senses, and then it's the sensed parameter has to be converted into a readable form. So you need a transduction element. In transducer, the transducer works in transducer, the work of the transduction is to sense and produce a measurable response to a change in a physical condition. In a physical condition, this transduction is to sense and produces a measurable response. Measurable response. Our human being has to measure that. So this is what is that. And then transduction element transform that output of the sensor. That output sensor is a signal. That sensed signal is to be transformed. It's transformed to an electrical or other form of converted energy. So these are the two very important elements of a transducer. It is not necessary that a transducer only consists of two parts. In some cases, a transducer will also consist of only transduction element which will perform. So in some cases, it is not always necessary that it should have a sensing element and a transduction element. Sometimes this sensing element will also act as a transduction also. One good example for such cases are given below. The thermocouple. You know about the thermocouple, how it works. Thermocouple means it is a thermal sensing element. Generates a voltage corresponding to the heat generated at the junction of a dissimilar metals. What do you mean by thermocouple? You have two different metals. One is positive temperature gradient and the other one is negative temperature gradient. So when these two metals are there, when heat is exposed to these metals, this will expand in different direction. Because of that, a voltage is generated in that metal, in that thermocouple. So this temperature is directly proportional to the voltage. So this thermocouple, here the temperature difference is converted into voltage. So this thermocouple is directly converting that. You don't need a transduction. You don't need an element to convert that signal, that converted signal into an electrical signal. It's directly converting. So this is what a transducer's basic operation or a block diagram. So a non-electrical quantity is given to a sensing element. This sensing element gives an output, that is the response, sensor's response. You have a sensor, you have a variety of sensors. So this is a response of that sensor, and this sensor's response is given as an input for the transduction element. This transduction element takes the input as sensor's response and convert it as an electrical signal. So this electrical signal will be stored in the memory. So the common range of an electrical signal used to represent the industry. In industries, mostly we are using this transducer in industries, industrial purpose. So there are variety of applications are there in tire manufacturing industries. As I said earlier classes, I have explained you in the earlier classes that the tire manufacturing process. So there are variety of sensors, temperature sensors, pressure sensors, humidity sensors. There are variety of sensors. So we will be using those sensors in the industry, it works between the 0 to, in the industrial environment, 0 to 5 or 4 to 20 milliamps. Normally, we will work in the 20 milliamps range. So now, we will see what is the classification of transducers. We have seen, now you got an idea, what is a transducer, what it works, what is the definition of a transducer, what is the alternative definition of a transducer, what is the block diagram, those things. Now we will see the classification of transducer. Based on its operation, based on its material quality, what we use, those things, the transducers are classified like this. Transducer may be classified according to the application where we are using. Then method of energy conversion, what kind of methodology we are using to convert from one energy to the other. Then nature of the output signal. So the transducer are classified as, based on the principle, based on the working principle, it is classified as capacitive transducer, which uses the capacitor principle. And then inductive transducer, which uses, this transducer uses the inductance principle, and the other one is resistive transducer. Resistance principle, working principle is used in this transducer. So these are the basic working principle. Transducer is capacitive transducer, inductive transducer, and resistive transducers. Then another variety is called the active transducer and passive transducers. The next one is primary transducer and secondary transducers. And then analog or digital transducers, the output may be an analog one or a digital one. Then transducers or inverse transducers, we will see one by one. So first we will see the active and passive transducer. What is an active transducer and what is a passive transducer? This active transducer, first let us see what is active transducer. This transducer do not need any external source. It doesn't need any external source. It works on its own. That these transducers do not need any external source of power for their operation. Therefore, they are also called as self-generating type transducer. The energy which is required for its operation is self-generated from this transducer. These are called as self-generating type transducers. The active transducers are self-generating devices which operate under the energy conversion principle. As the output of active transducer, we get an equivalent electrical output signal. Example is temperature transducer or strain gauge transducer, which converts the electric potential without any external source. You don't need any external source. The energy, the physical quantity, which means the temperature or the strain, this is converted directly into an electrical signal without any source it needs. Next is the, so this is the classification of active transducer. Active transducer classification is photovoltaic. You know about photovoltaic cell, solar cell. So when the sunlight falls on that solar cell, it directly converts that sunlight into an voltage. So this is the photovoltaic transducer. We will call that as transducer because the sunlight is a physical quantity that has to be converted into an electrical signal. Converted as electrical signal, we will call that as a transducer. So this is called photovoltaic transducer. The next one is thermoelectric transducer. The thermal heat is transferred into an electrical signal. Then we will call that as thermoelectric transducer. Electromagnetic transducer, electromagnetic concept, electromagnetic principle is used in this transducer. When there is a physical quantity variation based on the electromagnetic principle, this physical quantity is converted into an electrical signal. We will call that as electromagnetic transducer. Next one is piezoelectric. Pressure is converted based on the piezoelectric concept or the working principle technique. This physical quantity is converted into an electrical signal. Chemical transducer, chemical active transducers and other varieties of transducers. So let's see an example of active transducer, piezoelectric transducer. I think you will know about the piezoelectric crystals. What is piezoelectric? Piezoelectric means when there is a pressure is given to that piezoelectric crystal, a voltage is generated. This is what. So when you give some pressure to this piezo crystals, then and from the surface a voltage is generated. This is the concept or idea behind that piezoelectric transducer. When an external force is applied, to a quartz crystal, piezoelectric is a quartz crystal. So when an external force is given to that quartz crystal, there will be a change in the voltage generated across the surface. This change is measured by its corresponding value of sound or vibration. So where we are going to use this? This is an example. This is what is our physical world or our physical world needs. Our engineers plays a role. We want to measure the sound or we want to measure the vibration. How will you do that? So when there is a pressure, how will you get the pressure? When there is a sound. When there is a sound on that, you will get a vibration, you get a pressure. Or when there is a sound or vibration there, then you will get a pressure. Because of that pressure, some voltage will be generated there. So that voltage, that electrical signal is calibrated to either for the sound or for vibration. So you can directly, the calibrated value, you can directly read the sound or in decibels or the vibrations you can feel. The next one is the passive transducer. These transducers need external source of power for their operation. So this transducer can't work on their own. It needs power. It needs power for their operation. So they are not self-generating type transducer. A DC power supply or an audio frequency generator is used as an external power source. So you need to give a source to that. A DC source or a frequency generator is that has to be connected to the transducer. So it needs a power for that working operation. These transducers produce the output signal in the form of variations in electrical parameters. So these transducers will produce a signal which is in the electrical parameters like resistance, capacitance or inductance. So examples for this passive transducer are thermistors. You know about thermistor? Thermistor means thermal resistor. The resistance will get varies because of the thermal property. The potentiometer type transducers. Potentiometer type transducer means the voltage will get varies based on the movement. The next type of transducers are primary and secondary transducers. Primary, first kind of transducer. Secondary, next kind of transducers. Some transducers contain the mechanical as well as electrical device. It is a combination, some transducers, it is a combination of electrical as well as mechanical device. The mechanical device converts the physical quantity to be measured into a mechanical signal. Such mechanical devices are called as the primary transducers. So you have a transducer, it consists of mechanical and electrical. This mechanical transducer converts that physical quantity into a mechanical signal. Then this mechanical transducer is called as the primary transducer. Such mechanical devices are called as the primary transducers because they deal with the physical quantity to be measured. Then the electrical device that converts this mechanical signal. So the first part of the transducer which converts the mechanical movement or mechanical quantity or a mechanical parameter or a mechanical signal into a next level of mechanical signal, we will call that primary transducer. That mechanical signal is converted into an electrical signal. Then the device which is involved in that, we will call that as secondary signal. The electrical device that converts this mechanical signal into a corresponding electrical signal. Such electrical devices are known as secondary transducers. So we will see one example. This is a board-on tube. So this is to measure the pressure. When you give pressure to this board-on tube, this is a board-on tube. When pressure is given to this board-on tube, this exerts. This is the end point of that board-on tube is connected to the pulley. So when there is a movement or a pressure here, this pulley will pull that chain or a thread like thing. So this will be moved. So this is an input, this is your output. So here also you have mechanical quantity, mechanical parameter, mechanical signal. This is converted into a another mechanical signal. We will call this as the primary transducer. Then next, based on this movement, you can see this is, can you able to identify what is this? This is our interesting LVDT, linear variable differential transducer, LVDT. So what is that? Linear variable differential transducer. A core is varied linearly. Okay, so based on this movement, the core is moved here. When this consists of two types of the LVDT. Again, I will repeat it to keep it in mind. This LVDT can also be called as linear variable differential transformer. Linear variable differential transducer, also called as linear variable differential transformer. You know about transformer, it consists of two windings and one core. This is the basic element or parts of a transformer. You have an input coil and an output coil. The connecting parameter or the connecting part of this two winding is the core. Core transfers the magnetic energy from one coil to the other. So if the core is varied, magnetic flux gets varies. If magnetic flux gets varies, your output energy will get varies. So similarly, you have a source here. As we mentioned, this needs an external energy source. So this is a source. It is given to the primary winding. This is the primary winding. When there is a movement here, this pulley either pulls or pushes or pulls this core. So this core gets varies. If this core gets varies, the output in the secondary winding will get varies. Based on this movement, your generated voltage in the secondary will get varies. So this movement is this voltage which is available in the secondary winding is calibrated to this pressure. Can you understand now? We have given some pressure here. It is given to the Bourdon tube. So this pressure is converted as movement here through that thread or chain. It is connected with a pulley to the core. This core moves linearly. This movement varies the output voltage. This output voltage is calibrated to the pressure which is given in the Bourdon tube input side. So now you can directly measure what is the pressure is given in here. The pressure can be from anything. Pressure can be from vacuum pressure or any plant manufacturing places. There are various applications are there. Your what do you call that? Pressure tank, boilers, anywhere. So this can be converted. You can measure the pressure of that boiler tank easily with the help of this setup. According to the transduction principle, we have capacitive transducer, as I said earlier, electromagnetic transduction, inductive transduction, piezoelectric, photovoltaic and photoconductive transductions. These are the principle of the transductions. The capacitive transducer. What is the capacitive transducer? What is a capacitor? It consists of two conducting plates. In between the conducting plates, there will be a dielectric material. So, based on the area of the dielectric material or the distance between the two plates, the capacitor value will get vary. If I vary these two plates, the area will get varies. Depending upon that, your capacitor value will get, output value will get changes. That is what is X. This is the concept or idea behind the capacitive transducer. Capacitive transducer. Here the measurand is converted into a change in capacitance value. The measurand, what measurand means what? Measurand means the quantity which we are going to measure, which is called as measurand. Measurand is converted into a change in capacitance value. The measurand, the movement, which may be a physical quantity. This physical quantity is converted into a capacitance value. A change in capacitance occurs either by changing the distance between the two plates or by changing the dielectric. You can change the dielectric, either this is your dielectric, you can change the dielectric. These yellow colors are the plates, conducting plates. You have two conducting plates. This dielectric can be moved, or this plates can be area. The distance can be varied. So by varying this, the capacitance value will get varies. If that capacitance, the output value, capacitance value has to be finally calibrated to the movement or pressure or anything. This is our next electromagnetic transduction. This is our Faraday's laws of electromagnetic induction. You know Faraday's laws of when there is a current, when the magnetic flux changes, very simple, keep it in mind. When the magnetic flux changes, an EMF is induced. When magnetic flux changes, when you have a coil and this you are going to insert this permanent magnet, this magnet is going to be inserted in this. So a magnetic flux, you are changing the magnetic flux. When the magnetic flux changes, EMF, electromotive force or voltage, induced EMF or voltage will get generated. This is the concept of Faraday's laws of induction principle, Faraday's laws of induction principle. We will apply this concept to our transducer. In electromagnetic transduction, the measurand is converted to voltage induced in conductor, induced in this conductor by changing the magnetic flux. So similarly, you just relate to the previous example. So when you can whatever the parameter which you, the physical quantity which you are going to measure, you just connect it here. So either the magnetic field moves, the permanent magnet may either moves to this side or this side. So your induced EMF voltage generated will get varies. So it can be a positive voltage, it can be a negative voltage, it can be a minimum voltage, it can be a maximum voltage for 1 volt, 2 volt, 3 volt, 4 volt, 5 volt, anything it can be. So that voltage has to be calibrated with the distance or the movement, displacement, anything you can call. In electromagnetic transduction, the measurand is converted to voltage induced in conductor by change in the magnetic flux. In absence of excitation, we are not giving any excitation. We should not give any excitation. If we give excitation, then it is different. The electromagnetic transducers are self-generating active transducer. It works on the electromagnetic principle. It doesn't need any excitation. The motion between a piece of magnet and an electromagnet is responsible for the change in flux. Next is inductance. Inductance concept. We have seen the capacitive transduction, then the electromagnetic transduction. Let's see the inductance transduction. The inductive transduction measurand is converted into change in the self-inductance. In the coil itself, it is induced. The self-inductance of the single coil, it is achieved by displacing the core of the coil that is attached to a mechanical sensing element. Piezoelectric, we have explained earlier also the piezoelectric effect. When there is a pressure, a voltage is generated in there. In piezoelectric induction, the measurand is converted into change in electrostatic charge or voltage generated by crystals when it is mechanically stressed. Photovoltaic, as I explained, photovoltaic means, keep it in mind, photovoltaic is equivalent to your solar cell. When you keep the solar cell in the terrace of your building, that sunlight, when the sunlight falls on that solar cell, that solar cells or the photovoltaic cells convert that sunlight into a voltage. Okay, it directly converts. So in photovoltaic transduction, the measurand is converted into voltage generated when the junction between the dissimilar material is illuminated. It is illuminated. The materials are illuminated. Photoconductive transduction, the measurand is converted to change in resistance of semiconductor material. The resistance of that material gets varies because of photoconductive. Photoconductive means light, illumination, by the change in light incident on that material. What is analog? And the next variety is analog and digital transducer. What is this analog and digital transducer? Analog transducer means it gives an analog signal. What is analog signal? It varies with respect to time, functions of time. The time varies. So it is, we will call there are two types of signal. One is called the analog signal. In electrical, we will call analog signal and analog and digital signals. Analog signal means it varies with respect to time. And digital means you have only cut 0, 1, 0, 1 like that. So These transducers convert the input quantity. We are classifying the transducer. Keep in mind, we are classifying the earlier cases we have seen based on its working, how it works, electromagnetic, photovoltaic, those things. Now we are seeing an active and passive transducers based on the self-generate, whether it is self-generating or works on external power. This is based on the working nature, analog. The output is an analog signal or a digital signal. These transducers convert the input quantity into an analog output, which is a continuous function of time. Thus, a strain gauge and LVDT, strain gauge which measures the strain. LVDT, as I said, linear variable differential transducer or linear variable differential transformer. A thermocouple measures the heat, or a thermistor, again thermal resistor. Thermistor means you have to split. Thermal resistor may be called as analog transducer, has the given output which is a continuous function of time. Digital transducers convert the input quantity into an electrical quantity which is in the form of pulses, zeros and ones. What is transducer and inversion? So far we are discussing physical quantity can be converted into an electrical quantity. This is what we are discussing. Starting from this lecture, we are discussing about that. You can have the transducer from electrical signal to one physical signal also. In that case, we will call that as inverse transducer. Transducer convert non-electrical quantity to electrical quantity. Inverse transducer converts electrical quantity into a non-electrical quantity. In case of a piezoelectrical crystal, you can work on both the ways. When you give us pressure, it gives a voltage. When you give a voltage, it varies. The surface will get varies. So with this, now you got an idea what is a transducer. We have seen what are the things we have seen. Just recap. What is a transducer? What is its classification? What are the varieties of transducer? Active transducer. What is the block diagram of the transducer? This is what we have seen. We'll see the continuation of this transducer. This transducer is is a sensor. We have variety of sensors. Where we are going to use this? It is mainly used in measurement, instrumentations and measurements. So sensor is needed, transducer converts, then the data has to be stored at some place for retrieval. We have variety of examples, application. We will see one by one in the coming lectures, data acquisition system, etc. etc. Thank you.